Hi, Mr. Brown. Please give me an A on this assignment. I am very, very tired, and I don't want to do this anymore.
Human civilization has advanced in similar ways all around the world. Throughout history, humanity has been united through many different means. Every civilization has developed some sort of unique art or fashion, some version of a tasty dumpling dish, and scary murder weapons to kill each other with. Through time, these murder weapons have developed to be more and more sophisticated, and we know them today as guns. Kapow. Okay, today I'll be explaining the physics behind Today I'll be explaining the physics behind guns.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Hi, Mr. Brown. Welcome to my physics culminating assignment. The first devices identified as guns appeared in China around 1000 CE. These weren't anywhere similar to what we recognize as a gun today, using gunpowder to shoot fireworks out of spears. Needless to say, this version of a gun wasn't very good, and it wasn't until the 13th century that the Chinese invented true guns, guns that you and I would actually be able to recognize. You could say that the Chinese had to do a little bit of troubleshooting to get it right. These new guns were metal barrel firearms that fired single projectiles from the barrel. Gunpowder and gun technology spread throughout Eurasia during the 14th century and developed through the years. All guns, from rifles to handguns, are based around the same basic firing principles: a projectile, the barrel, and a propellant. Gunpowder is almost universally used as a propellant, and bullets are almost always used as the projectile. Guns use the force of a propellant to project a missile. They're classified by the diameter of the barrel opening. This is known as the caliber of a gun. Anything with a caliber of up to / including .60, which is also known as 0.6 inches, is known as a firearm. When the trigger of a gun is pulled, the hammer hits the firing pin, and the firing pin then hits the primer, which causes the gunpowder to burn, which produces a very hot burning gas. The gunpowder burns very, very fast, and it sort of explodes. The sudden expansion of gas is a result of the exothermic reaction. The increasing temperature increases entropy, which we know due to the laws of thermodynamics, stating that the change in free energy, G, equals the change in enthalpy, H, minus temperature, T, times the change in entropy, S. Gunpowder ends up in a gaseous phase, with the entropic force guiding the bullet. The gas has a volume of hundreds of cubic meters at this temperature, which is a lot. Also, the driving force in this reaction is the exothermic nature of it, as it is in all redox reactions. Not only is this thermodynamically fascinating, but if we look at the ideal gas law, we can see an interesting trend. PV equals nRT, also known as pressure times volumes equals moles times gas constant times temperature. We can see as pressure or volume increases, so does the temperature, and vice versa. Basically, this causes the volume of space behind the bullet to fill with extremely high pressure gas. The gas pushes on every surface it encounters, including the bullet in front of it, the base of the gun barrel behind it. The increase in pressure caused by the gases causes the bullet to be forced into the barrel, then out of the muzzle at a very, very high speed. Once the bullet's fired, it remains in motion from its momentum. The momentum will carry the bullet until it strikes an object or until gravity pulls it back down to Earth. Also, firearms change potential energy into kinetic energy in the actual firing process of the gun. The force imparted by exhaling the bullet is not the only force acting on the gun, or the shooter for that matter. Most modern guns are also spring-loaded, where huge amounts of potential energy are forced into the springs of the gun, and pulling the trigger releases this energy, allowing the hammer of the gun to hit a primer which ignites the gunpowder and, as previously stated, pushes the bullet out of the barrel at a very high speed. This conservation of momentum is also demonstrated when the bullet hits an object, assuming it hits an object before the force of gravity brings it back down to the Earth. The object that it strikes absorbs the kinetic energy from motion and momentum. If the force of momentum from the bullet is great enough to overcome the mass of the object, the target will be moved along the same vector as the bullet. To increase the accuracy of the flight of the bullet, a technique called rifling can be used. Rifling is where the barrel of the gun or the bullet is creased with spiral grooves that allow air to pass through. When the bullet's fired, the air passes through these curved grooves and spins the bullet. The spinning action allows the bullet to cut through the air more efficiently and fly on a truer course, stabilizing its trajectory. For example, a 180 grain or 12-gram bullet fired from .357 Magnum handgun can achieve a muzzle energy of 580 foot-pounds force, or 790 joules. Ouch. You don't want to get hit by that. Please give me an A. This took a really long time to make and to edit, and honestly, I'm kind of on the edge here. I have a lot of lab assignments to do, and I don't really want to do. So if you could kind of just...
Built by the science guy. Built by the science guy.
Please give me an A, Mr. Brown. I'm not joking right